Alright, this is part 2 of how to do reactions that have gases in them. Notice I have solid, gas, solid, liquid. I want to be careful on this one. And watch as we go along. This one's not very difficult, but if you're not watching carefully, it can get you. What happens if you're not at STP? Just a quick reminder, if you're at STP, then 1 mole of any gas is 22.4 liters, only at STP. But what happens if you're not at STP? Let's see this question. How many liters of hydrogen gas, it wants to know how many liters of hydrogen gas at 35 degrees Celsius. So you automatically know it's not STP. And it says that you are at 0.980 atmospheres. Will need to react completely with 875 grams of tungsten oxide. Well, this looks like it's going to be incredibly difficult. To work the problem, you've got some weird things in this question. They give you a pressure and a temperature. The very first thing you're going to notice, it is not STP. It's not STP, so you can't do that. But the other thing we've just learned is pivnert. So here's the trick. If you can't use STP for 1 mole and 22.4 liters, use pivnert to help you. Alright? Well, whenever you go to work a problem like this, you know that you can't be in grams. You're going to have to change 875 grams to moles. Now watch what happens. Oops, excuse me. Mole doesn't go there. Grams goes here. Mole goes here. What number goes with mole? A 1 every time. So we're going to take tungsten, and we're going to figure out how much tungsten weighs. I have to look that up in the back of this book. I don't have this one memorized. Tungsten has a weight of 184. 184. Oxygen is 16 times 3 is 48. So again, I'm going to use my handy-dandy calculator to make sure I get all the numbers right. 184 plus 48 is 232. 232. So 875 divided by 232 equals 3.77 moles. Now, I'll sort of circle that so you can see it. Now the question says, how many liters of hydrogen? Am I in the hydrogen column? No, but I can get there because I'm in moles. So when I'm in moles, I can jump to any column. I can calculate all of them. It just wants this one right here. So what I'm going to do is I'm going to take 3.77 divided by 1, which is 3.77 times 3. So 3.77 times 3 is 11.31. What units? Moles. That would be the answer if they wanted moles. But the question asks for how many liters there are. Well, I'm not at STP, so I can't use 22.4, but I can use pivnert. Notice what I have at this point. I have 11.31 moles. I have 0.980 atmospheres. That comes from right here at the top. They tell me it's 35 degrees Celsius, so 273 plus that is what? 308.15. So I don't need that anymore. And if I'm in atmospheres, it's 0.0821. So my X is volume. And what's that going to come out in? It's going to come out in liters, just from doing pivnert. So if I take this and divide by 0.980, that disappears, and I'm going to have my answer, and it's going to be in liters. So I'm going to take 11.31 times 0.0821 times 308.15 equals divided by 0.980. My answer is 291.97 liters. See if that shows up on the screen. Yeah, it does. And that's how you work the problem. So when you go to work problems with reactions, if they have gases and they need liters, there are 2 things you need to know. If you're at STP, 22.4 is your best friend. If you're not at STP, pivnert is going to be your best friend. They will give you all the information to plug your answer right into the equation. So here's what I'm going to do. I'm going to give you an equation. I'm going to let you try it, and then we're going to come back and answer it together. Remember, all the math is still the same. You can only work the problem in moles. So let me give you one, and then we'll work it together, and then you'll have some worksheets to practice on. All right? All right. What is the mass of sulfur that must be produced? Okay, so it's going to be sulfur that must be produced. Excuse me. What mass of sulfur must be used to produce gaseous sulfur dioxide at STP in the following equation? Okay, so they're going to give this to you. I completely read it wrong. Let me just start over. My apologies. Here's the reaction. S8, that's a solid. That's a weird looking formula. Don't worry about that. Don't let it bother you. 8O2 produces 8 SO2s. All right, so you have a solid, you have a gas, and you have a gas. All right, the question says, what mass of sulfur? They want to know this in grams. To produce 12.61 liters of that at STP. So you're going to start at 12.61, see if you can get that answer. Go ahead and pause the video. We'll come back in a second, see if you can get it. All right, when you go to work this problem, S8 sulfur, solid, plus 8 oxygens, and I told you it was STP. So you're going to be at STP. Your magic thing you should have done was 12.61 liters. 22.4 liters is mole. So I'm going to take my handy dandy calculator. 12.61 divided by 22.4, and that is 0.56 moles. Now, can I get over here? Sure. I'm going to take 0.56 divided by 8 times 1. So 0.56 divided by 8 times 1 is 0.07 moles. They want grams, so I'm going to take 1 mole, grams. Well, sulfur is 32, so 32 times 8 is 256. So 0.07 times 256 is 17.92 grams. How could I do that? Because of this fact right there, 22.4 liters. Here's one more for you that you can try on your own. I'll do a better job of calling it out and writing it down, and then you can check it with a neighbor when you're done. How many grams of water can be produced in a reaction using oxygen and hydrogen gas? Okay, so you're going to have hydrogen gas and oxygen gas, and you're going to produce how many grams of water? Okay, first thing you want to do is balance it. I'm not going to give you that, but you can do it. You're smart. How many grams of water? So they want to know how many grams of water can be produced from a complete reaction of 3.44 liters of oxygen gas at STP. All right, so there's the problem. Works just like the last one. See if you can get the answer to that question. At the end of the video, which we're about to end, after you work it, check with the neighbor and see if you get the same answer. Good luck.